Now we'll assign the beam end release condition to the hangers. So again, in the boundary tab, select beam end release, click on add replace, and to see better I will unactivate the section. To select very quickly these hangers, you can go in this part of the screen and select Z in the filters. Now if you select all, it will only select the hangers. For the condition of the end release, select MY and MZ and just click on apply. So you will see there's a small symbol green, which is now which is now here on each end of these hangers. To assign the other condition, unselect the Z axis in the filter and click on select element by identifying. Here choose section and select bracing and stringer add. So this is a very quick way to select all the bracing and stringers in your model. Again, fix M, Y and MZ and click on apply. Now again, click again here, section, and this type select the cross beam, click on add, and here we'll activate only these elements. So go in the view, activate only. What we will do is to select only these parts of elements. So for that, click on here and intersect line, and if you click here, only these elements will be selected. Now in the condition, select pinned fixed and click on apply. Now select the other element here, and this time select fixed pin and click on apply. Now you can activate all the elements, and we finish to apply all the boundary conditions. I will then create a cross beam group. So this is necessary in order to enter the moving load. So click on select entity, section, select the cross beam section and add. Activate only these elements and choose the top view. Now you can close this, right click on group and right click on structure group, click new, and here you can enter the name cross beam 1, enter. Select the elements here, so you can use this, and if you drag and drop the cross beam, all these elements will be assigned to your cross beam group. So I repeat, this is necessary to do that in order to apply the moving load on these cross beams. Next step is the definition of the load cases and the definition of these loads. So click on static load case. Here in the name you can enter the name of the first load case, which will be dead load. The type you can choose dead load, click on add. You can enter now sidewalk load, click on add and close this window. Now we will create these two. go into the load tab, click on elements beam load element here, select the dead load for the load case, click on add, select uniform loads, global Z for the direction, and here actually you only have to add the value of this dead load, which is minus 90. Then click, you have to select also the main girder. So to select the main girder, you have to go in here, element, section, main girder, add. Okay, now you can click on apply to create this dead load. For the sidewalk load, this is the same, so you can select again previous. You just have to change the load case for sidewalk load, uniform load, global Z, and it will be minus 6 for the value of the load. Click again on apply to create the sidewalk load. Now we'll see how to define the moving traffic load. So in load, you have moving load here. For the code, you can choose the code you want to use. So in this case, I will use the ASHTO code, LRFD. You have first to define the traffic lanes. So click on traffic lanes, click on add, and we have to define the 4 lanes. So you have to define the eccentricity of the lane. So for the lane 1, use so before entering the values, I will change the unit to the British unit. I will use KIPS and the foot. Okay. Now for the eccentricity, enter minus 11.5. The wheel spacing will be 6 feet. The cross beam, click on cross beam. And so here you see that the cross beam group you defined previously is here. Now you have to select the 2 points for the traffic lane, and you see it has been added here. So click on OK to create this traffic lane. So you can see it here. Now we'll create the second traffic lane, and lane 2. Eccentricity this time will be minus 35. Select cross beam, both for the moving direction, and again select these 2 points and click on OK to create the lane 2. Now that we've created the traffic line lanes, we can close these windows, and we have to define the type of vehicles. So click on add standard, and here select the code ASHTO LRFD load. For the load's name, you can just use this one, vehicle load type. OK, and for the dynamic load allowance, use 33. Click on OK, and we'll click again on add standard. Okay, same standard, but this time we'll use the 93 TDM standard and use again 33 for the dynamic load allowance. Now click on OK. Now close the window and we'll see how you can add the moving load cases. Click on moving load cases, click on add, enter the name MVL for moving load. You can use the default scale factors and click on add here. First vehicle class, use this one, scale factor 1, 1 for the minimum number of lanes and 2 for the maximum number of lanes. Select these two lanes and put them into the selection lane window. Click on OK. Now click on add again to add the other vehicle class. Scale factor 1, 1 and 2 for the maximum number of lanes. Again add these two lanes. Now you can click on OK and you have defined your moving load case. Now it's the time to define the analysis control options for the moving load. So go in the analysis tab, click on moving load, and here you can define all the analysis options. So we'll use exact, all points for the line point selection, and we will use 5 for the number of line elements, normal. For the frame, we'll use normal, and all for the reaction, displacement, and force moments. Click on OK.